So hi everyone. Today we're going to talk about how AI is transforming test automation. Oh my god. What was I thinking? So in my defense, I'm Israeli and we're used to giving big old outrageous statements and then getting in trouble. Uh, so my name is Daniel Gold, and back home I work in a company called Testim.io. You can visit us via www.testim.io. So Testim.io is an Israeli startup. The R&D is based in Israel, and we have another base in San Francisco, and we work with customers worldwide. And what we do is develop an AI-based test automation framework. So I'm the head of QA and automation at the company, and I'm also a blogger. I have a technological blog in which I write about software testing, methodologies. I spill my heart out. I talk about the frustrations of the occupation and some technical reviews, some test automation and DevOps stuff. I did a review about Docker and containerization. Did a review about Selenium 4 as it was about to be released. And I'm also a lecturer and a speaker. And back home, I have a company called Gold Training, and I provide advanced test automation and DevOps courses to individuals and companies. And I think that pretty much sums up me. By the way, this is the URL to my blog, so you are all welcome to visit and slay me in the reviews, and I promise I'll get better. You know what? Enough about me. Let's talk about you. I want you to please raise your hand if you're confused about the terminology of AI, machine learning, deep learning. If all these things aren't definitely clear to you, please raise your hand. Okay, so I don't see a lot of hands up, so someone who didn't raise his hand could please explain to me what AI is if you're also confident about it? Yeah, it's quiet all of a sudden. So here's the deal, guys. As time goes by and AI raises in popularity, I see more and more famous speakers going on stage or writing professional articles and addressing AI as being something, well, in a word, negative, right? Difficult to contain, difficult to control, difficult to test. I'm sure you read that opinion article about it would be a disaster to send out autonomous vehicles and autonomous trucks on the road, right? And I get it, really. I get it. Because nowadays it is very hard to have your own opinion because they're bombing you with information they would like you to hear. There are all these big old news items they do about robots will take over our jobs soon, right? You probably heard that one. And AI, autonomous vehicles, AI triggered autonomous vehicles are a disaster and all of that. But you know what? The problem is that when asked to describe AI, many people fail to do so. So I want you to please raise your hand if you think that AI is the source of all evil and soon it will take over our jobs and all that. No, no hands up? Yeah. Okay, it didn't work for them. So I have good news and I have bad news. The good news are that Testim as a company, though we do deal with AI-based technologies, we solidly believe, and me personally as a tester, I personally believe that no technology will ever replace you guys. The human manual or automated tester, his hands, his experience, his error guessing, his eyes, his look and feel of the product. And that is my personal point of view. And the bad news are that in about 5 minutes, I'll be replaced on this stage with a robot, and I guess he has other plans. Yeah. So the agenda for today. Look, we're going to do like a breakdown of AI. We're going to discuss the key concepts of AI, and then we're going to shift all of this discussion closer to our home base, right? Closer to our field, which is software testing and test automation. And we're going to see the effect AI has on that field, okay? And then we're going to do like a little glance in the future of what AI has in store for us. So first of all, I'm here to pronounce AI is already here. It's here and it's embedded in our lives more than you can ever imagine. If you ever interacted with Alexa or Siri, or received a recommendation for the next Netflix movie to watch, chances are you were interacting with AI. We know this from social media. We have automatic age guessing, right? Facial recognition, automatic tagging of people in photos. We just woke up with this feature one day on Facebook, right? Well, I hate it because I don't like tagging people in photos, but if you do enjoy that kind of stuff, think about how much clicks it saves you, how much screens it saves you from going through until you find that person and tag them and approve and upload, right? It just gives you a way to do that faster. From the transportation field, guys, we have autonomous vehicles and auto parking, right? Tesla and Audi doing a fantastic job. They're not perfect, but come on, who's perfect, right? A perfect software does not exist, and if it were to exist, we would be out of jobs, and we don't want that. Google search. Google search, guys. We will receive different results when searching the word Java, dependent on whether we are programmers or coffee makers, right? Because the algorithm will study who we are and the things that we, let's say, volunteer about ourselves to Google, right? Yeah, I heard that one. So it will provide an output based on what he knows about us, which is kind of cool. It makes us search for things faster and easier, right? Now, all of the examples we discussed is taking data that we see around us, and using that data to perform tasks and to answer questions and to help us do chores which manually or in a more primitive way would be much harder to do. Now, it's kind of cool because if you think about it, everything around us is data, right? Everything is data. So the basics of AI. Look, this is not supposed to be a technical lecture, so I'm going to make this very, very simple. AI stands for artificial intelligence. So AI, machine learning, deep learning, neural networks, it's all a subset of a data-related science field. What this technological data-related science field addresses is giving computers the ability to learn without being explicitly programmed. Now, I've mentioned that we can use data to answer questions and to perform tasks. But before we move along to some kind of a simple demonstration of how we can use these kind of algorithms, I want us to get familiar with 5 key concepts, 5 keywords that will kind of like guide us through the next lecture and help us speak on the same language and be on the same page, okay? So the first one is trading data. Everything around us is data. I've said it, this is correct. But we have to find unique enough and representational enough data to provide to our algorithm to learn. We then have to tag this data, okay, sort that data, and create patterns and modules inside of our algorithm so it could recognize these patterns. In that way, it could receive an input and provide an output, right? The last concept is confidence level. In a nutshell, what that means is how sure I am that the output I provided is what I needed to provide, is what the user would expect. Let's take a look about an example. So let's say we're developing some kind of a very primitive algorithm that is supposed to receive images, okay, and recognize images of vehicles, right? So we're going to take like 100 pictures of cars, right, different models of cars, like bomb it to our algorithm, and tag them as vehicles, right? So in that case, if the 101 photo will be of a model of a car that the algorithm didn't see before, with a high level of confidence, it will know that this is in fact a vehicle. Why? Because it has 4 wheels, and it has a steering wheel, right? And it has 4 doors, like in a windshield, right? And it kind of in the shape of a car. You know this old American saying, if it walks like a duck, sounds like a duck, it must be a duck, right? So it must be a car. All of this is giving an input and receiving some kind of an output. By the way, this looks like my neighbor's dog. It keeps barking all night long. I swear to God, I lose sleep. So what I've just discussed in a nutshell is called supervised learning, okay? Now, nowadays, AI is the next big thing, right? It's a huge buzzword. Everybody wants to do AI. They're shoving AI into pieces of software. Everywhere has AI, right? But quite surprisingly, this piece of technology exists for years. For years, guys. And I see by the looks of your faces that you don't believe me. So I've prepared an example. So the next example I'm going to show you is a video of one of the first autonomous vehicles ever made. It was made by the Robotics Institute. It is powered by an artificial intelligence software called Alvin. Okay, and the vehicle is called the NavLab. Now, this particular video will be from 1989, guys. As early as 1989, and it is, I think, the NavLab 2, because the NavLab 1 was super slow. But I want you to think about something. 1989, guys. Think about the computers we had in that era, okay?
Years ago, who would have thought that cellular phones would be as common as they are today? Well, we may be thinking the same thing someday about our next story. CMU's Robotics Institute is developing a car that can drive itself, and it's already being tested on the road. Money editor Bill Flanagan went along for the ride.
Todd Yoakum is behind the wheel of this Army ambulance, but the CMU graduate student isn't driving. A computer is. The machine watches the road through a video camera perched above the windshield and steers the vehicle itself.
We've had it up to 70 miles an hour, and it's driven autonomously for over 90 miles straight without the human ever touching the wheel.
That's right. This robotic vehicle is driven to Erie and back on I-79. It's the result of 8 years of military research at CMU's Robotics Institute. Scientists here don't teach computers how to drive. Instead, they use a computer process called a neural network to create a machine that can learn to drive. Dean Pomerleau is the project director.
We don't tell it anything except steer like I do. Learn to steer the way I'm steering right now. Sometimes it keys off of the road edges. Sometimes it looks for the painted lane markings down the center of the road. So it varies, and it learns in different conditions what important features are on that road type.
At slow speeds, the NavLab can use a laser rangefinder to spot and avoid objects in the road. But to date, it's too nearsighted to do it at highway speeds.
It may be a while before you'll be able to buy a robotic car that can run on down to the convenience store on its own. But perhaps not so long for robotics technologies pioneered here at CMU to begin showing up in state-of-the-art cars and trucks.
The Robotics Institute recently received a more than $2 million grant from the U.S. Department of Transportation to find ways to use the military technology to improve highway safety. Chuck Thorpe's the principal investigator.
So I think the most important part of this entire video is actually the first few seconds when she said, years ago, who would have thought that cellular phones would look the way they do? But I think today, if I would have gone back in time and showed that lady my cellular phone today, she would fall off her feet. Like her hair would like turn gray on the spot, right? Because it's like cosmic technology. But think about it. That technology progressed with time to help us do tasks and to help us do it easier, right? Easier. And that autonomous vehicle was designed with a purpose also, to help the human driver avoid accidents, because all of the lethal accidents performed until this day, well, most of them were done by human beings, right? Quite surprisingly. So I wanted to show you one more quick demo of what we can do with AI. So we have this like little demo website called Quick Draw by Google. Okay, and what it does, they fed it with numerous images, okay, created patterns and modules of these images, and then it tells you, okay, so draw this image, and you try to draw it, and the algorithm tries to guess what you are drawing based on these patterns, okay? So let's see an example. Okay, let's draw. Draw a zebra. Oh my God, okay. There you go. I'm lousy at drawing.
I see garden hose, or river, or diving board, or the Great Wall of China.
What?
I see mustache, or cloud, or ocean,
It does not
or
look like the
mountain.
Great Wall
I
of
see
China.
mouse, or mouth. I see squiggle, or line, or camel, or horse,
come
or
on.
stairs. I see octagon, or bear, or knee. Sorry, I couldn't guess it.
Okay, one more. Tooth. I can draw a tooth, right? It's addictive, I know.
I see line.
Okay,
I
it's
see
a
ocean,
Mac, I'm sorry.
or beach, or bird,
Oh,
or mouse,
come
or
on.
garden hose. I see comet, or ring, or magic wand, or squiggle.
Magic
I
wand,
see
yeah,
thin
like
finger,
that.
Or music note, or unicycle. I see snowflake, or hurricane, or hula hoop, or
Hula hoop,
seahorse.
yeah.
I see tornado. Sorry, I couldn't guess it.
You know, last one. Bracelet, okay.
I see snake, or matches, or lit match.
I
or
didn't
toothbrush.
draw
I
anything.
see garden hose, or seahorse, or blueberry, or stethoscope. I see onion, or mouse, or wristwatch, or cherry. I see computer mouse, or
come
swan,
on.
or cello, or violin. Sorry, I couldn't guess it.
Spoon, last one, okay.
I see line, or matches, or diving board, or lollipop. I see bread. Oh, I know, it's spoon.
Oh! I think this is the highest point in my career. I can just retire right now. So in my defense speaking, two things we can learn from this. The first one is how training an AI via feeding it images would look like. And the second one is I suck at drawing. Okay, back to work. Okay, something I'm good at is test automation. So how does this entire thing relate closer to our field, which is test automation? Look, if I take you back on the timeline, tools have been more adapted to the way we do things, okay? So not so far ago, not so long ago, we had more time to do stuff, right? We had different approaches to developing software, and then the big bad agile wolf came, right? And everything has to be ASAP. And tools. We had bulky test automation tools, which take like a week to install, right? A month to learn, and then your computer would like jam up for a week. Followed by the open source revolution, right? With Selenium achieving something I can fairly describe as global domination, right? Selenium and Appium. I was at Dan's talk in Kiev about a few months ago. And today, with the era of continuous delivery and continuous integration, the DevOps era, right? Another big buzzword, but everything has to be more frequent, and we break things on the daily basis because of our fast pace. But if we take the main challenges of test automation, in my opinion, we can narrow these down into 5 main clauses. So the first one is skill set. So how can we define skill set? Well, the skill set will vary between the tools, right? We have codeless automation tools, which will require learning. We have code-based frameworks, where you get nothing but API libraries and bindings, right? You get nothing. You have to write your own tool, your own framework, your own infrastructure. And authoring time. Well, before you get to authoring, you have to write your infrastructure. I worked in one company where we had 8 to 10 months to write only an infrastructure. 8 to 10 months, guys, of paying our salaries, of manual testers performing regression manually. And before you get to an ROI, return of investment, it was ages, okay? Correct planning. You know, one of the, in a startup, everybody wears a few hats. So one of my super interesting roles at Testem is kind of like you can define it solution architecture. So I go to our customers' headquarters and I kind of like take a look at their product and their issues and their goals, and together we come up with the best way possible to implement test automation at their organization, which is kind of challenging because there is no one-size-fits-all approach, right? Every company with their challenges, their skill set, right? Their team, their product with their Angular magic, right? So it's very interesting. And one thing I tell everyone, so before you write a single line of code, plan your project. Get a piece of paper, get a pen, list what you want to automate. What are your building blocks? What your architecture needs to look like? What are your project dependencies? How would you automate this? And this is a big pain spot in many organizations, which just run to implementation without planning. And then after you have test automation, it doesn't stop because you have the maintenance factor, right? Because we break things very, very often. And of course, scale is something every organization strives to. Now, due to barriers of time, we're going to talk about maintenance and maintenance only. How can we define maintenance? Before we define maintenance, I want you to answer a simple question. How do test automation tools locate elements inside of our web page? Anybody wants to answer that? So, selectors, okay, that's right, you're correct. So, excluding CSS selector and XPath, which provide us a more flexible way to locate elements, we're still going by a single unique identifier, right? A name, an ID, right? But if you come to think about it, each one of you in the crowd has a first name, right? But I can tell someone else so much about you to describe you without mentioning your explicit name, and that person will know for a fact I'm talking about you without me mentioning your name. The same thing with web elements. Now, if you come to think about it, what is a DOM actually? What's a DOM? HTML tags, CSS, JavaScript, XML, right? All that cool stuff kind of like mashed together into something called a document object model. But what is it? It's data. This is data we can use. So how can AI help us in that not simple at all mission of test automation? Well, at Testim, we saw that opportunity and we implemented something we call dynamic location strategy. What that means is if I want to capture an element and to perform a click on it, I can capture it via every property I can collect upon it. And there are tons of properties. Okay? So I want to show you a quick demonstration of how it would look like. And I'm going to cross my fingers and pray that the internet connection is sufficient. Okay, so this is the tool. This is something we call an editor. And I'm going to like give it a base URL for my application under test. Okay, and we're going to start recording something, right? So I'm going inside here, clicking on login, entering my username, entering my password, right? Logging in, dragging the slider, right? Clicking on select destination, and I want to add like a text validation, right? Validate element text that I have reached this screen, right? This is my exit point. And I'm going to close it. Now I want to play this test case. So I'm playing it. Okay, so it inputted my credentials. Green means it passed. Okay, dragging the slider, boom. Clicked on it and test completed successfully. Now, that is all good and very, very easy, but what happens if I take a real life scenario? So here comes the UX guy and says, you know what? You see this select destination button? I don't like it. Let me just put a breakpoint right before I click on select destination and play it again. Okay, so it reached that breakpoint. So you see this button, I don't like it. So I'm going to click on inspect. Okay, I get the DOM. And I see there is this button. It has a text, select destination. Select destination is boring. I'm going to write TestCon rocks. Boom. Okay, so I have changed it, right? TestCon rocks. You know what? I don't like this. Let's go back. You know what? I see this ID here. Where is it? Okay, there it is. Okay, I don't like it. I'm going to break this ID. I don't like him. So I'm going to call it Daniel ID. Boom. Okay. You know what? I don't like this entire element. I'm going to move it. So I'm going to click on cut. And I'm going to paste it like 3 divs above. What do you think about that? Paste element. Okay, so I demolished it, right? You see, TestCon rocks, and it moved its way up the dome. So do someone want to tell me what would happen if this test case would have written in Selenium? Boom, right? My laptop would explode. So this test case would have failed because I've destroyed a lot of properties I could find about this element. But let's see what happens in testing. I click on play. Boom, it clicked on it. It's green. Why? So if I take you to the side-by-side view, okay, which is a cool way to root cause analysis, right, to debugging, and I see that, in fact, the recorded element looks different and the text is different and it's in a different location, right? And if I take you to the locators that we found here on this step, right, we can see that the target element, we didn't find the text because I broke it, right? And we didn't find the ID and we didn't find the index. We can see it's grayed out here. But with 83%, which means with a high level of confidence, my algorithm knew that this is in fact the element. Okay? Now I'm gonna jump ahead for a second, and I know what you're gonna ask. Wait, this is a false positive, right? No, because a validation would have failed. But all I wanted to do here is to click on this element. Okay? I'm gonna ask it in a different way. If that step would have been a validation instead of a clip, would I want to find the element to perform the validation on it, right? So the validation would have failed, but all I wanted to do is to click on this button, and this is one of the strengths that AI and these algorithms give us to deal with these kind of dynamic locators. So when we're not supposed to deal with changing domes and updating our test cases with new business logics, right? Then we can focus on narrowing the coverage gap. Okay? That brings another meaning into narrowing the coverage gap. So the future of AI. Look, eventually, if we can capture elements in our dome, and we can study, we can collect patterns, then we can take real-life user scenarios on production websites, and we can turn them, aggregate them into real-life scenarios, right? And turn them into test cases. So this is like, in a very, very shallow nutshell, is what AI has in store for us and what we can do using these type of technologies. So before I go and leave you alone, I have been entertaining you for 45 minutes or so. I wanted to tell you two things. The first one is, I think that it was Steve Jobs' quote. He said, "The world was designed by people no smarter than you." And I think that nowadays it is, in fact, very difficult to have an opinion of your own, but we're all testers, okay? First of all, we're testers, and we're bombed with information from so many angles, but our job is to question, okay? Not just blindly believe every opinion column. That's just what it is. It's one opinion, okay? We have one of our own. So as testers, one of the things I look for in my team and people I recruit is people who are judgmental, who do not take things for granted. They learn, they always strive to progress, and tools progress with us. Okay, so I think that the main message of everything we saw today in every demonstration is that years ago we never would have thought that these things are possible, the things we do with technology today. And the second thing I wanted to tell you is that you have been an amazing crowd. I want to thank you from the bottom of my heart for listening, for coming to hear my talk, for laughing of my bad jokes. And I want to thank TestCon for inviting me. It's been a tremendous pleasure. Thank you very much.